so thank you. You know, I do what I can. All right, I'm going to let everybody introduce themselves. How about that? We can start with you, Jeremy, and then we'll go all the way down. So give me your name, tell me your position, who you're with, and I guess why you're here. How about that?
Oh, okay. Well, my name is Jeremy Fischl. I'm a principal scientist at Sanctuary, and I'm here because you asked me to, and
Okay.
I
feel like I'm going to be getting that answer a lot, right?
I'll go next. Hey everyone, I'm Ani. I'm a partner with McKinsey and a company, a reforming engineer, so I have a PhD in engineering. I've been spending the last decade or so in strategy consulting. I'm here because I'm excited about robotics and I'm hoping to bridge the gap between the people developing the technology and the end users who are excited to adopt the technology.
It's a much better reason.
Yeah, we can like try again. We'll loop back around.
I give him $10 to be second.
That's good stretching.
Hi everyone, my name is Erin. I work for Toyota Research Institute, where I lead a team with a way too long name called Opportunity, Discovery, and Technology Adoption. So my background is as a robotics engineer, worked in field robotics, academia, biomedical, food manufacturing, and now in Toyota. So the thing that we do in our team and we're really passionate about is we are embedded in a research institute. We have amazing researchers doing really cool things and they all want to make an impact with their technology. So my team's job is to find the pathways out into the world, whether that's through partnerships, spin-outs, spin-ins, developing it end-to-end. We help do some of that strategy work as well as some of the execution work to go from research to something that looks more like a product.
Hi, my name is Rohit. I'm a general partner with True Ventures. We are an early stage investment firm that invests across a variety of areas, including robotics. My own investment interest, since I'm an engineer, I should say I'm a lapsed engineer. I haven't really engineered real systems in a couple of decades now. Tend to be in autonomous systems, applications of computation, machine learning to a variety of physical real-world systems. So we've been lucky to invest in a variety of robotics and supporting technologies. And the reason I'm here, since Brian asked, is because Brian asked really good questions.
Okay, so it was a good answer. We bookended it with that answer. So we thought this would be an interesting panel because we brought together 4 people who do just completely different things in this field. Technical, VC, consultant, research. We thought it'd be interesting to have a conversation around some sort of broad topics and see where we agreed, where we disagreed. And let's start here, though. Let me start with a big question, and then we can kind of like take it and make it a little bit more conversational as we go along. As we sit here, getting towards the end of 2025, humanoids have obviously been a big topic of conversation over the last several years. What would you say is sort of the single largest challenge facing the humanoid field as far as really being able to scale this technology in a meaningful way? We'll start with you. Okay, we'll start with you, right?
That's easy. There is no shortage of challenges.
Yeah.
I think just about every facet of robotics is challenging. I think the humanoid debate maybe gets dominated too much by the physical form factor. Where we are really interested in and focused on are, do we understand the function that machine is supposed to do, and what part of that could be automated, what part of that could be autonomous, and what part of that then could be autonomous and collaborative with humans and with other robots, because there's no scenario in which we only have one kind of robot, right? Or one kind of robot, there'll be many. So the challenges to me are twofold. One is the work, which is I think one of the frontiers of engineering today. It's some of the most interesting work you could do if you're an engineer. So every system, navigation, perception, the physical, mechanical movements, arms, where we haven't really made progress for a couple of decades now, tactile sensing. You saw the speakers earlier talk about it. So those are all challenges in the engineering sense. I think on the thinking part, there's maybe an even bigger sort of pyramid of challenges. How do these systems perceive other entities, human or robotic, or machines? How do they declare their intent? How do they declare their presence? We don't really have that today. So that entire software part is very tough and meaningful to actually get right before we talk about whether it should be bipedal and have 4 arms, 2 arms, whatever. In fact, one of the things I want to maybe ask my fellow panelists here is, we are so fixated on the physical form, I think we've lost sort of track of maybe they should be modular, maybe this is a entity that goes and picks up the end effector it needs. It picks up wheels when it needs it, or bipedal feet when it needs it, or 5 arms if it needs to do that work, right? We're not really getting to that problem yet, and that bothers me as an investor, because our timelines are artificially short. We're looking at a 10-year timeline or 12-year timeline. I think in robotics, we have a much longer timeline to prosecute.
We were talking about this before, and I perceptions about that, I think it shifted dramatically. Obviously, early on, there wasn't a ton of modularity. Modularity is a difficult problem. You're an engineer, you understand that. I think probably most people would agree that modularity would ultimately be good to have, right? I mean, they're in agreement. It's just a difficult challenge. Is that fair to say?
I'd agree that it's a challenge, but it could be beneficial. I mean, I think the biggest problem we face is not just, we need to get past looking like a human and get towards performing like a human. And I think the community gets like very fascinated by capability, like, wow, we folded a shirt, but that's so far away from doing that at a speed and a quality that anyone cares about. So our focus largely is on getting to human-like performance. We kind of define this as competency. So, not only can I do a task, but can I do a task at a speed and a quality that a customer finds acceptable? And we'll accept any technologies to get there. We look at, some of these more anthropomorphic designs for inspiration. It's like as an existence proof that humans can do it. This is a fair design to start from, but we're not fully committed to that. We want to get to the performance, and if modularity gets us there, we're first on board for that.
Does performance mean at this point, does it mean outperforming humans?
I'd be happy to get anywhere close to the speed and quality. We're nowhere near that.
Yeah.
The term that Andrea used this morning I love, which is minimum viable humanoid, right? What is that form factor? Let's get to that, because it'll do that minimum level of maybe human-like performance in some areas. I think that'll be a good starting point.
I think the shift that I hope happens as well is there's a lot of technology-forward conversation in the ecosystem, and I think it needs to shift to like the value-back conversation, right? What tasks are you automating? What is the economic value of that task being automated? And therefore, what's the right technological solution, whether it's modular, whether it's a humanoid form factor, whether it's a wheeled robot that allows for that to be automated. I think we've arrived at a moment where, from my vantage point, the last 6 months have been very exciting. We've had 200 plus conversations with companies ranging from shipyards to automotive manufacturing to aerospace to power generation systems to medical equipment manufacturers. We're all looking at automation and robotics, but I think they're missing the gap of, well, what is the useful thing that I could do with this robot, right? I don't have towels to fold. Yep. What can I get it to do?
Erin, one of the things that I appreciate, that I know that you appreciate about how TRI is positioned, is that you don't have any particular allegiance to any companies or any form factors.
Yeah, it's something that we're very grateful and I guess blessed in the position of being a research institute, is that we can make multiple bets. And so we're taking an approach of diversity. Maybe it is a legged system and one team is looking at that. Maybe it is a wheeled system and it's more practical. We really like that opportunity because it gives us a chance to truly learn from each other, but also learn from the use cases of when does it make sense. And also, there are still a lot of hard problems in this. And so sometimes we choose legs not because it's the right solution, but maybe because it unlocks the right next thing to research. Or maybe we choose wheels because what we're trying to do is actually not the hardest research problem for mobility, but it's more about what does it mean to adopt this or commercialize this.
Yeah, so, and this kind of relates to, I think, what Ani was talking about. Something I'm really curious about TRI research institutes in general is, I know that you come from a DARPA background, that you were working with the Subterranean Challenge. How does an institution like TRI, how do you pick your challenges?
Yeah, it's actually a harder problem than it seems on the surface.
The challenge of picking challenges?
The challenge of picking the challenge. So the opportunity discovery part of my team is somewhat this, is that it looks like market intelligence, sometimes business intelligence. We're out in the factories, the places that we have access to, looking to these problems to help inform the research strategy, because that enables technology adoption on the outside. We want real-world scenarios that we're building our research against, because it makes technology adoption so much easier. However, real-world scenarios can be really messy and really hard, and it's really difficult sometimes to measure your progress. Are we truly moving the state of art of the robotics forward? So we actually have a process that's inspired by DARPA, where we set ourselves challenge tasks. So these are tasks that we're not necessarily intending to solve as a build a product, but they give us the ability to do something that is real world and has some of this messiness and difficulty to it, but it also lets us measure. So we do a lot of thinking about what are the right tasks that pushes the state of the art, but also lets us measure in a way that we know we're improving. So the example that we use right now is, and it's served us for about 6 years now, is mobile manipulation robots that we put into a shopping scenario. We are not trying to build a shopping robot. However, it's a really hard problem of manipulation. If you think of all the things in a grocery store, from the apple to the 1 kilogram bag of rice to opening the fridge. And so this is a really good challenge task because it's very hard, it's a lot of diversity, but it's also really measurable. So every quarter we send our robots out into a real store with an operations team. They give it a shopping list and say, go shopping robot. And it's a way for us to measure how well are we really improving this capability. And then once we start to see some of these foundational capabilities prove resilience, then we start going, let's move out of the challenge task domain and into something that is a little bit more practical, knowing that we've measured and we know that this base capability is somewhat performant, and now how do you tackle the messiness of the real world?
So speaking of like really difficult problems, Jeremy, this is something when I knew you were going to be on the panel that I really wanted to talk to you about specifically. You've been at Sanctuary for a bit, and something that I only actually realized fairly recently is that you came on board through an acquisition that you've been in, I guess, tactile sensing for a long time now. And speaking to a lot of embodied AI, physical AI companies recently, my understanding is that like far and away one of, if not the most difficult challenge right now is contact manipulation. How hard of a problem is that? Why is that such a hard problem, and how difficult is that to scale?
Yeah, I'd say tactile sensing is, I think there's like 3 prices of admission to studying this. Like one is understanding how hard hands are, and then understanding how important tactile sensing is, and then understanding how hard tactile sensing is to do. And if you don't have these, if you haven't come to this conclusion yet, you're way behind the curve. But tactile sensing is an incredibly difficult thing to get right in a durable, cost-effective form factor.
So something in an industrial setting, and it can be repeated over and over again, and yeah.
And these policies need the sensors to be stable over long periods of time. I don't know if it's just, oh, there we go. Need to be stable over long periods of time. And if they drift in the performance, the policies fail. So trying to have durable sensors that don't break. And they don't need to do sophisticated things. I've been saying this to the tactile community. Like, they're too feature rich. They just need to do basic contact and not break and be cost effective, which is something we're focused on at Sanctuary. And my team's leading the development of some very durable and simple compliant tactile sensors that could be patterned over larger regions of the body. And that's very critical because the timing of contacts is very difficult to extract from vision. So if I wanted to pick this up and I don't have touch, I kind of have to go, do I have it? Yes, I do. And then move on. Whereas when it's just touch, you don't have to look. You have that confirmation signal. It's rapid and responsive.
And it goes back to your point of, is the robot going to perform at a level that makes it useful versus it can do the task, but it's not really useful for me if it does it very slowly.
Yeah.
Yeah, and Ani, I mean, I assume that this is a conversation that you and McKinsey are having a lot with customers, with companies, because the other huge problem right now that I think we're maybe not talking about in a very realistic or pragmatic way is scalability. What are those conversations like? And you know, when we're throwing out these I won't name any names, but when we're throwing out these like really huge astronomical numbers in the next 5 to 10 years, like how realistic are they, and what is it actually going to take to get anywhere close to those figures?
I think so there's sort of a technical conversation that I'm by no means the right expert on this panel for.
Well, yeah, you can also defer as much as you need to.
I think the way sort of Erin framed the sort of shopping cart example, I think there is a expectation mismatch between seeing that shopping cart perform those mobile manipulator tasks and then someone thinking about, a inbound logistics warehouse for an automotive factory and saying, that's kind of like doing grocery shopping. So that robot should apply. When you're trying to bring these in an enterprise context and scale, the initial POCs and pilots will get a lot of support and a lot of excitement because robots are cool. Beyond that, you have the CFO who gets involved, who is cutting a large check, will want to see operational performance improve against that check. And if the technology isn't ready, sort of it behooves the ecosystem to do that sort of education of, we're here, we're showing the art of the possible. We want you to get prepared for when the technology is ready versus, go and announce that you're going to buy 5,000 robots tomorrow that are extremely slow and clunky. And then it sort of, there is precedent here of 10 years ago, people trying to adopt robotics, it not playing out, and then becoming monuments inside factories that go as an evidence point of failed deployments. And I think we should, as an ecosystem, avoid that sort of misfire and really shape, how do you go from opportunity discovery to the actual deployment readiness of that particular set of tasks.
This is something that we feel a lot, like we're in these deployment stages, and a lot of it has to do with educating your partners as well, because they sort of come to it, and this was talked about earlier today with the GXO, of they expect you to be like a vendor, and they're like, cool, great job, you did the demo, now we want to scale this to 100. But it's a completely different relationship, because the promise of these mobile manipulators or humanoids is this idea of scalability and generalization. Whether that is a humanoid form factor or a modularization, the idea is that I can take it from this task and it's going to work on this task and it's going to work on this task. And so a big piece of the education we're trying to do with our partners in these pilots is we can't just show you in one scenario and make it work. We're not trying to build solutions, we're trying to build tools. And the only way to show tools is that we make it work here, and we make it work here, and we make it work here. And at that point, we can have the conversation of, should we deploy these? Because, and that's an ongoing conversation and a lot of sort of customer collaborator teaching, I guess, that has to go along with this.
Yeah, and I think ultimately when you want it to be scalable, you want the end user to have some level of capability to figure out how do I take the tool and where I deploy it versus you having to sort of handheld for every single robot that gets deployed.
I think that's the bet of humanoids essentially is that, this more complex general purpose system at the appropriate scale and being able to repurpose flips all the economics around so it actually does make sense.
Yeah. Now, Rohit, you mentioned Andrea, and I don't know if people are aware of this, but you were early, 9 years ago, investor in Diligent.
Yeah.
One of the things that she was talking about was minimal viable products, like what problems can we solve now? Brad, who I think is in the back there, was talking about this as well. Like what can we do right now to bring this to market? And when you're doing investments, when you're looking at a company like Diligent or Kelkar or whomever, I mean, are you as an investor, are you having that conversation like, hey, what can we do to get an ROI right now in the market?
Yeah, I think that's it. Part of defining and understanding the problem fully. Do you understand what proposition you bring to the customer, and the customer understanding out of the 20 things they can automate, these two are the right ones. And then that's not the only win. The win has to be on either side of those two as well. The marginal efficiency really matters. I think Amazon did a great job in figuring out of the 15 steps, which two to automate. And we're not invested in Cobot, but I love Brad Porter's take on it, that this is how you solve the problem, right? You have a approach that melds well with the environment and saying, the environment part is the other often overlooked part. If I'm an engineer, I'm trying to solve a problem, part of it is providing the machine, but the other half is modifying the environment it's in. We have always done that, right? So if I'm going to be in a warehouse, at some point I shouldn't be getting 100 human-like things moving boxes from point A to point B. How about I modify the way the boxes are stacked, moved, and arranged in that space, like a space about this kind should be arranged completely differently if I'm going to have robots actually moving whatever it is to be moved. Have I looked at what the unit mass has to be, the volume, what's the trade-off? Why isn't it a 3D Tetris-like system that moves all these things without needing a automated, mobile, singular robot, right? So we look for those signatures. Now, what stood out with Andrea 9 years ago when we invested and led the seed round was their ability to understand what the hard pieces were and their arrangement of how you solve this problem, and identifying human-robot interaction is a very big deal. It's the most overlooked piece, and it's a very big deal. Now, they're going to hospitals, right? Who should the robot listen to? We had a couple of the speakers here talk about that. That's a massive problem, right? Should they listen to everybody who goes by? Should they listen to nurses? Should they listen to doctors more than nurses? Yes, and maybe no in some scenarios. What if out of a group of 12 nurses, there's a temp nurse that day that has no authentication, has a badge, but is sort of a guest in that environment? Do they listen to that? So I think that area is very big and complex, and the right answer there is to understand it by placing a robot in that scenario, which I think they've done a remarkable job in getting a couple of hundred into hospitals today that are working every day, making these deliveries, learning what it's like and which tasks are practical and which ones are not. Those, I mean, for us, the decision to invest at that point with Henry and Vivian was natural that, yes, they understand this and they understand the environment and they understand the business proposition. And then we've had another half a dozen robotics investments, all task-focused robots. Yeah. The general purpose point I understand that Jeremy made, I think it's very critical. Eventually, long-term, it's general purpose machine, but then as an engineer, I sometimes think, like, is that us projecting our understanding of what we built with information technology, servers or mobile phones, things that were abstract and things that could then be parallelized massively, or GPUs, right? And then there are general purpose tools that we use to solve other things. But they interact with environments that are more or less fixed, and the variable piece is software. Robots are not like that. Like, they don't just have bits and bytes, they have atoms to deal with. The physical world is not similar to software. So respecting the complexity inherent in the physical world is part of the challenge here. And I think that often gets overlooked. So while on one hand, I'm widely excited about the robotics area, I am fearful of some of the projected near-term scenarios that begin to pop up in press, which I don't think are very well informed about humanoid-like things, 10,000 of them, 50,000 of them, picking up some car part and putting it on, or picking up a bin and putting it there. The engineer in me sort of revolts against that. That's not a good way to solve that problem. Fix the bin, change the bin's shape, change the way it's stacked, change the way that whole rack moves first, before I attempt the robotic part of it, which is a mobile on wheels or bipedal.
Yeah,
Right?
I mean, that gets to, it's the Greenfield versus Brownfield conversation, right? And this is something, you know, it relates to obviously a lot of A3's mission statement as far as being involved in manufacturing and factories is what can we do to get, to kind of insert ourselves into the workflow without completely disrupting the process? And that's been, that's a piece of humanoids, right? I mean, that's one of the promises there.
Yeah. I mean, I think we're not talking about tasks that could be automated by traditional means. We're dealing with labor shortages and people not being able to find workers to do jobs they can't find people, they can't automate it, and these people are having production issues, and we're trying to tackle some of those problems. And I get they're kind of long horizon, but they're important problems to solve in the long term. So making progress. We will still come up with working blocks that can be deployed and added to conventional automation to make early progress, because getting to product's critical here as well. We can't just promise humanoids for decades ad infinitum and keep getting money for it. That's for sure.
And I think building on what you'd said earlier, Jeremy, was I think the framing of task-specific robot is very appealing in sort of an industrial context, but I think we're going to run out of room for how many tasks exist that will deserve sort of an end-to-end product development cycle just to automate that task. And the promise of general purpose is all of these building blocks that you build change the economics of being able to take those building blocks to automate incremental tasks that otherwise by themselves aren't a large enough market to automate. And that's what gets companies that have labor shortages really excited about this. And the question is, how do you do that? What are those stepping stone deployments, whether it's mobile manipulators or other form factors, that still are on that roadmap to a more general solution?
I guess we need to have a frank conversation then of what the ultimate goal is. You know, Rohit, at the beginning you're mentioning a collaborative, right? You know, certainly that's a potential promise of humanoids. It's not a reality right now because there's a lot of safety concerns, right? We talked about dynamic stability. These things power down, they're gonna fall down, they could hurt people, that's a problem. It is, and feel free, anybody, to take this and tell me your opinion on this, because I'm of like more than two minds on this, but is the ultimate goal of robots, of humanoid robots in an industrial setting, is it to really continue to be collaborative with humans in the industrial setting, or is it ultimately to create lights out, closed loop, fully automated processes? I think you're probably good to start with this.
I think we've had quite a few conversations where there is an aspiration for that lights out sort of operation. I think reality is, if you ask a lot of, a lot of these sort of end user operators, if they actually knew very granularly all of the physical tasks that take place,
sure,
and if those tasks are executed to the T, to the work instructions that were provided to the operators, I think other than sort of Brad's example with Amazon, I think you'll come up with a very short list of people who actually know what happens.
I think you'll find that a lot of people in sitting in boardroom offices don't necessarily know what actually happens on the floor, yeah.
And it's a lot of sort of problem solving, that years of doing that task in the line and switching different jobs that people have sort of developed that isn't written down, so which tells me that there is likely enough edge case scenarios where a collaborative scenario is more likely than a true lights out scenario. True lights out scenario, unless you adjust the environment, you adjust the production system, feels like a heavy investment, questionable ROI type model.
I think switching to my personal opinion here,
okay.
For political reasons. I think lights out.
You're also in Canada. I don't know if that impacts this conversation at all.
I'm in California, but yeah, sure. Yeah. So I think this ultimate goal of trying to replace all people, workers with robots is a terrible idea, strictly from people who are creative and intelligent and solve problems. And if you took all the people in a factory and replaced them with a robot, there will be no improvements. There'll be no people to go, I've got a better way to do this. It'll just stagnate, and the next human factory will overcome that in productivity. They don't. And so I view this as, these are tools to enhance productivity. I want to make it so that normal people can program robots to do productive work, rather than what's currently done with like industrial automation engineers that go and visit a cell and try to figure out how to automate this. I think the people working there know what to do, and if we could give them better tools to be more productive, everybody wins.
This is like fundamental to our strategy. That's why I talk about tools and not solutions. And it goes way back to Toyota's history in looms, where they talk about automation with a human touch. And so the robots that we're building, this concept of collaboration or a teammate, is absolutely fundamental to what we do. And I think about the business challenges of robotics and why people are trying to hit generalization, because it means that potentially we can scale and the unit economics work, but a huge blocker to that generalization is not just the form factor and not just the AI, but this human-robot collaboration and the HRI that goes into that. And so we tend to put that at the forefront of the way that we think about this, is to to really change the whole business structure of how the robotics economy works, because the value chain at the moment requires integrators, it requires these crazy specialists that when the robot goes down, you need to be able to call them up. And maybe when you had a point-to-point robot that just did the same thing 1,000 times and you could program it once and you bolt it down, you don't touch it, that value chain maybe made sense where you have these integrators in place. But now if you're in these environments where it's super dynamic and everything's changing all the time, does it really make sense for these big customers to have to call these experts every single time and be like, oh, I need you to reprogram the robot or it's failing in this scenario? And so the whole economics changes about the value chain and all the people that are involved in supplying these robots to these customers. And so you have to have really good human-robot collaboration where a non-expert can retask a robot and say, today we're going to go do this. And maybe it's through language models, maybe it's through some of this drag and drop programming challenges. Many people are used to the pendant style thing, but we need to reimagine the whole value chain so that there's not all of these extra steps that make robots too expensive and fixed for these customers to use.
Rohit, I feel like you're going to have an interesting, I feel like this is going to be an interesting perspective from you based on two of your investments. One, we were talking about diligence, so obviously healthcare space, healthcare workers, particularly nurses, infamously overworked, particularly during COVID. But then beyond that, bare flag robotics. So, for those of you who don't know, AgTech tractors, they were acquired by John Deere, and I assume that it can probably be difficult to sort of sell to markets like that sometimes, insofar as they have their particular ways of doing things. And I suspect that probably the conversations that both of those companies' founders had with their clientele early on were very similar from the standpoint of their concerns about jobs being replaced by automation.
I think that's a valid concern for a very long time. It doesn't go away. So the collaborative environment, like Jeremy also alluded to and others, yes, I think that's a noble goal. Are humanoid form factors the best way to address it in the initial phases is where my disagreement lies, which is the affordance of that figure, the signal of that figure is a human equivalence. And we are very far from that. I mean, we had the speakers from NVIDIA earlier. We are not quite at a worker's level of intelligence with gigawatts of GPUs over farms that train LLMs and do inference, right? We are getting there. And I'm an optimist. I'm going to bet that happens. But I'm a very skeptical optimist because I'm not going to make irrational bets either. So I think when you map that kind of thinking into robotics, it's a two-part problem. It's a learning data reasoning problem, which is in the software domain, but it's also an atomic problem in the physical domain. Robots live in a three-dimensional world. That is not like other machines. And if we don't respect the complexity inherent in it, I think we come up with the wrong answer. And that's where I'm fearful of some of these projects that look and feel interesting and emotionally because of that figure that looks like a human and therefore in our mind should work like a human, right? But that's a very big gap from where we are and where the trajectories are of some of these systems, at least over the next decade. Now, going back to Diligent Bare Flag Robotics, what we liked was with Diligent, Andrea was very clear. I'm not making a robot operate or be in between a doctor and a patient anytime soon. But I recognize there's a 500,000 nurse shortage going to 2 million in the US over the next decade. How do I best address that? Which is a clear, understood problem by the hospital administrators. And this is really the 13th person on a 12-person nursing team. That's the robot. And now you have changed the framing and the task list and what it does. And it returns, I mean, I don't know if she talked about it earlier today, it's joyful for the nursing teams to get this robot. Any of the pilots they had, the nurses refused to give it back after the pilot was over.
She's got all these photos of them taking selfies with them and dressing it up.
Which is unprompted. I mean, they made TikTok videos of how great it is to work with Moxie, the robot. Now, bare flag robotics is slightly different concern where we have a massive shortage of labor on farms.
Yeah.
And the farmers are expected...
And frankly, recently it's getting a lot worse.
Yes, I'm not a U.S. citizen, so I can't get into that debate. But it's interesting, farmers are expected to be everyday scientists, right? The weather is changing, climate has changed, all of their past patterns no longer apply, and then the real life scenario, from the biome in the dirt that they deal with, to the crops they have to grow, to the markets they have to go sell into, all of that is changing, right? So any amount of automation would be a win, but they still have to pick the right kind. I think, to my mind, they picked a very good one, which is 75 to 125 horsepower tractors that could go do that. So by the time the farmer is up at 6 a.m., 6:30 a.m., a lot of the work has been initiated and started according to both what they want and what's optimal for that particular farm. So we tend to favor solutions like that, and there's a few others. Sites Robotics, which is autonomous grass mowing machine, AvidBots, which is almost 7-8 years into the investment as well, the world's best autonomous floor cleaning robot. They clean millions of square feet a day, right? But to me, that's a great first step. Is that the eventual outcome? No, I think we still want to be delivering technology in service of humans.
Yeah.
So I like that element. I would love that element to continue, but when it comes to manufacturing, when it comes to metal manufacturing, for example, sustaining current suboptimal practices isn't the right answer either. I can't forge and mold metal the way I did 50 years ago and add to the carbon load. So I need to find a better way. And if that could be robotic as well and doesn't require a human operator in that nasty environment, I think that's a win. So I think these are not generalized answers to some extent. They vary by industry, right? Can I foresee cars being made that, one, they should be mostly software defined in the next few years, and can they be made in a 100% automated line without any human touch? Yeah, I can see that. I can see that in 10 years. I can't see a humanoid working alongside me in the kitchen in the next 10 years, though.
Okay. So 10 years, and you know, everybody on this stage, everybody in this room knows this. I've been a tech journalist for a very long time now, and it's like 5 years from now, 10 years from now, 5 years from now, 10 years from now. Can anybody on this stage or even in this room like disabuse me from this idea that I keep going over in my head over and over again, that like we're being sold self-driving cars 2.0, and that the football keeps getting kind of pulled away, or the goalposts are going to keep getting moved, year by year by year.
I spent quite a bit of time earlier in sort of the ADAS and AV space, and I think sort of from the end point, it's probably a similar story. However, because of the investment dollars, the talent, the focus that humanoids have attracted, there are lots more stepping stone problems to be solved in robotics than there were in the self-driving car space. Self-driving car space, you almost had a bifurcation of the L2, L3 sort of ADAS space, and then the robo-taxi market. There were some, I would say, geo-fenced applications, but that sort of intermediate ground in robotics is a lot more fertile. There are a lot more things that we can solve because of the excitement and the attention and talent and money that it's drawing.
Well, I mean, there was a lot of money and talent and excitement in autonomous driving too, right? Obviously, and like Google was getting involved and Uber was getting involved. There was money being thrown into that.
But you still only had roads that were to be driven on. You didn't have a set of, the shopping cart example. You didn't have a machine tending example. You didn't have a inspection example in the field. You didn't have a solar cell installation. So there are a lot more subtasks that this talent can then go solve than I think there were in the AV space.
I guess maybe, and I don't know, maybe Erin can take this, but I guess, so it's like the 99.999% accuracy problem. It's the safety problem. It's the problem of self-driving cars, like one accident right there, and that's going to set them back 10 years sort of issue. It's where they're deployed. It's if they're in, cages versus obviously we're seeing all of these like home robots and dealing with babies and dealing with like elderly people, things like that. I mean, so there are different modalities.
Yeah, I actually started my time at TRI in the automated driving division before it moved over to Woven Planet. So it does feel the same. There's very much this, like, it's very exciting, there's lots of cool stuff. When you're in it, as an engineer, you know it's really hard, and there's this long tail, and you're watching the industry, and there's a lot of funding, and there's a lot of talk about it. So it does feel the same, and it does feel like there will be this in 5 years. But I do agree that I actually feel like this robotic space is probably harder because of this goal of generalization. Because it's not confined to the roads. It's almost like saying not just the roads of America that or Europe that we're going to build automated driving, but we're going to do it in Delhi as well, and then outback Australia.
I love driving in Delhi.
So the scope of the environment really adds that complexity to it, and if the goal is really tools that can be applied in all of these various domains, that's a really long problem to work on.
I think as a VC, I have to comment that the VCs do get excited by things that, from an engineering perspective, are easy to get to 80% completion. It's sort of like the weird version of Pareto principle, right? So in self-driving around 2010-11, getting to 80% became easier. There were LiDARs I could put on, there were cameras I could put on. I could demonstrate something that looks really interesting for somebody to pile money into.
The first time
robotics has that.
I visited Pittsburgh and sat in a self-driving Uber that was like undeniably incredibly cool.
It is. I've done lots of Waymo rides because it's in San Francisco and in Palo Alto now, so I do that routinely. With the constraint problem they have, I think Waymo has done a very good job in solving that. Now, look at the data they collected to learn the environment, though, right? That is not a trivial amount. That is not possible by most other entities, but they took on that challenge 15 years ago and have made reasonable strides. But it's not a generalized solved problem yet, because I think the exceptions and anomalies keep coming up. It's a dynamic generation of exception and anomalies in that environment, which is what I fear for home robotics, for example. My home is constantly full of anomalies, right? So no, we're not going to have a chef robot because it has to deal with exceptions most of the time. And those are the hardest engineering systems to design, right? I can't design for this sort of middle of the curve anymore. I have to worry about corner cases because they're much too frequent to ignore.
Here's the good news, though, is that maybe, self-driving cars aren't necessarily where we wanted or hoped they would be, but without all this research, we wouldn't be having this conversation about humans right now. All right, so we've only got about a couple minutes right now, so I'm going to open it up to questions. If anybody in the
We got
audience,
maybe one or two quick questions
Yeah.
here. I'm in the middle. We got Dana on the side.
this young gentleman.
All right,
in
we'll
front,
let you.
Sarah.
I've been. I know. Here you go. We'll get you one more. Here.
So my question is, do you see there's a foreseeable future where there is a robot in everyone's home?
There you go. There's the $10,000 question everybody's
Does
been
that
asking.
include Roomba?
Is there a humanoid robot in everyone's home?
Okay, humanoid, okay.
I mean, I'm the most skeptical. I'd say there are going to be robots, not just one, but it's our failure of imagination that we only conceive of this singular human-like figure, right? It could be a pile of cubes that self-assemble. It could be a main cube that gets power somewhere, gets wheels somewhere, gets an arm somewhere else and does the task. And I mean, don't forget the iPhones that we all have, generation on an iPhone 25 in a few years, which might be the better brains for that versus putting it in NVIDIA GPUs and Jetson boards in every small device. So it may not look like what we think today, but will we have more robotic behavior enmeshed in different physical form factors? Yeah. Will it be a bipedal robot of the kind that's being sold for, somebody had the Unitree thing here for $18,000 for the developer model? Probably not. That's my take.
I'm very optimistic. In fact, I joke with my family quite often. I say, I can't wait to be old. Because I'm generally excited by the future of when I'm 80. I think the things that we're building now, unfortunately, they're not going to be ready. And I think about service, particularly for the elderly and aging, keeping them at home. And I wish that I could give that to my grandparents and my parents. I don't know that that's necessarily going to be true and ready. Maybe for me, maybe for my children. But I see it as living in a house with a fleet of different robots with different skills, different roles. And I'm very optimistic and excited by that future.
Yeah, I think for me personally, I don't know if 10 years we'll have humanoid robots in homes, but I agree with the idea of we will have some form of robots that are available to consumers to interact with in a safe way that will pave the path for, hopefully when we're 80, there to be sort of service robots to live in your homes.
I don't know if I want that. I get annoyed with the Roombas in my way. So I don't want some humanoid robot in the way. And I like doing chores with my family, and I think my wife appreciates that I help out around the house. And no, I think it's a bad idea. But maybe some people's homes.
Not yours, not everybody's, everybody else's. Thank you so much. This was a pleasure. We got a reception, I think, coming up. Robert will tell you all about it. Hopefully some of these folks will be there and they'll answer the rest of your questions. Thanks, everybody.
Thank you.